Hey there, physical science students. This is Miss Ruark, and I'm getting you ready for your Chapter 11 test on motion. So here are some sample velocity calculations that you can try on your own before you watch this, and then you can check your answers with what I've got. All right, so if you want to, go on ahead and pause it, solve the problem, then come back and check it with your answers, or with my answers, excuse me. All right, suppose that a line moves due east at different speeds so that it travels 25 kilometers in 4 hours. And what's the line's average speed? All right, so analyze the question first. What are we looking for? We are looking for the average speed, so we're looking for S. The important information in this is that it moves due east. Remember, we underline everything. Suppose that the line moves due east. That gives us our direction at different speeds so that it travels 25 kilometers, which would be your distance, and 4 hours, which is our time. Okay, is there anything else we can circle? I don't think there is. Okay, now, I'm not circle, underline. Now, we've underlined everything that we see in the problem. Does that mean we need to use everything? No, because we're just looking for speed. And we know that speed is equal to distance over time. Right? We don't even have to rearrange this equation. That's awesome. So we plug in for distance, which is 25 kilometers, and we plug in for time, which is 4 hours. And we solve. Before we solve any math, what's going to happen to our units? Are they going to cancel? If you said no, you're correct. So kilometers per hour. And then 25 divided by 4, put it in your calculator. And you should get 6.25 kilometers per hour. All right, so on average, this line's moving 6.25 kilometers per hour. All right, well, it wants to know what's the average velocity of the line. Okay, now remember, we have to have direction to go along with that. It's the same thing as speed. Velocity is equal to distance over time. It just has a direction. Okay, so we put in 25 kilometers, and we put in 4 hours, and we solve, and we get 6.25. The only difference is that it's going 6.25 kilometers per hour east. Okay, so that's the difference between velocity and speed. You need to make sure you know the difference. All right, next problem. In 1926, Gertrude Ederle was the first American woman to swim across the English Channel. At that time, she set the world record for crossing the channel with an average speed of 0.725 meters per second. Assuming that the distance Ederle swam was 37,900 meters, which is the shortest distance between England and France, how long did it take her to swim the channel? All right, so this has a lot of fluff in it, which is stuff that you don't really need to solve the problem. It just gives you extra information to set the scene, I guess you could say. All right, so what are we looking for? It's saying how long did it take her to swim the channel? So how long did it take? Okay, that's a measurement of time, right? All right, so then in 1926, Gertrude Ederle was the first American woman to swim across the English Channel. Is that important? Sure, because it's a record, but not for this problem. Not for calculations anyways. At that time, she set the world record for crossing the channel with an average speed. Oh, that's important. Average speed. There we go. Of that. And assuming that the distance she swam was, oh, there's our distance. Okay, the shortest distance between England and France. How long did it take her to swim the channel? Okay, but we don't have a direction. We don't have anything else, right? Okay, so we know that speed is equal to distance over time, and we're solving for t. So we've got to get t by itself. All right, so best thing to do is multiply both sides by t. That'll leave you with t times s is equal to d. But we want t by itself, so we need to divide both sides by s. So t is going to be equal to d over s. All right, now we've rearranged the equation, and so we just plug our numbers in and solve for t. All right, our distance, 37900 meters, and that is divided by 0.725 meters per second. All right. Now remember, if you're dividing by a fraction, you actually end up multiplying by the inverse. Okay, why am I saying that? Because our units. Okay, meters divided by meters over seconds is the same thing as meters times seconds over meters, right? That's the same thing because that cancels, right? So we end up with, and it's not going to be meters times seconds for our velocity, or for our distance. It's actually going to be, oh, we're looking for time. That's right. So those cancel and we're left with seconds. I should pay attention to what I'm looking for. We're looking for seconds, which is time. And so that's how we get our units. Our units will be time, which is seconds. And now all we have to do is plug in 37900 divided by 0.725. And the calculator gives us a really big number. 5,2,2,7,5.86. I'm just going to round it to 9 because I'm running out of space. Seconds. So that's how long it takes her to get across. Okay, it's not reasonable to think of it in terms of seconds, but because we haven't worked on conversions to go to minutes or hours, we'll leave it at seconds. Okay. All right. Bonnie Blair set the world record for women's speed skating in 1995 with an average speed of 12.9 meters per second. How far would Blair have traveled at this speed in 300 seconds? All right, so what are we looking for? How far would she have traveled? So we're looking for distance. And we know that important stuff. Is 1995 important? Well, it is a number, but it's not important for our calculations. We're going to keep going. Average speed of 12.9 meters per second. Yeah, that's important. That's our speed. And how far would she have traveled in 300 seconds? Well, that's our time. Right? So we know that speed is equal to distance over time, or velocity is equal to distance over time. We've got to get d by itself, so we've got to multiply both sides by t, which will cancel the t on this side. So t times s is equal to d. Okay, and then now we have to plug in. So for t, it would be 300 seconds. And we're going to multiply that by the speed, which is 12.9 meters per second. Okay. What happens to our units? Well, seconds divided by seconds, they cancel. So we're left with meters in our answer, and we do 300 times 12.9, and it gives us 3,870 meters. There we go. Okay, so that gives you technically four different examples for velocity and acceleration. You just have to remember how to rearrange the equations so that you can solve for the letter you're looking for. All right, and that's it for this one.